All right, guys, Mr. Arnold here again. I want to talk a little bit about Chapter 15, Section 2, physical and chemical changes, physical chemical properties. Make sure that we have all of that stuff kind of in our head and know what we're really kind of talking about when it comes to the formative assessment and moving on from there. So we're going to start out with physical properties and physical changes. Physical properties are the properties that we can observe using our five senses. That's the size of things, the shape of things, color, could be odor. If we're talking about sulfur, it has a very distinct odor. It smells like rotten eggs. So that's one way that we can describe sulfur's properties is by its smell. Yeah, that was a little bit loud. I apologize for that. You know, size, is it big? Is it small? Is it, you know, in between? Shape, is it a square? Is it rectangular? Is it round? Surface, is it rough? Is it smooth? All of those would be physical properties of matter. And the reason why they're physical properties is because they don't have anything to do with changing into a new substance. It's literally just describing what we see. Physical changes of matter is whenever we change the matter without changing the actual substance into something brand new. So if we cut it, if we chop it, if we rip it, all of those would just be simple physical changes. The question we always have to ask is, really, can we kind of put it back in to what it once was? So if I take a piece of wood and I chop it in half, can I kind of put it back together and still have the same thing, which is wood? And the answer to that is obviously yes. Phase changes, so if I go from a solid to a liquid to a gas, again, the question, can I return it back to its original substance without changing it? And yes, we can do that through phase changes. If I take ice, I melt it, it turns into liquid water, and then if I take the liquid water, put it in the freezer, it freezes back to ice. It's just a simple physical change. Some other examples of physical changes are density, melting, boiling points, shape, and I spelled color wrong down there, but color as well is another example of a physical change, physical properties. Taking a look at chemical properties are properties of matter that result in a new substance being formed. So this is where maybe we bake something, a cake or whatnot, and it goes from the eggs in the batter to the fluffy cake and what we're used to tasting as a nice, delicious cake. Some examples of chemical properties would be reacting to light or to energy, flammability, can I catch on fire or not? Does it rust or tarnish? Does a gas form? Is there a change in the smell or odor when substances are mixed together? Or is there a solid or a precipitate that forms when two substances are mixed together? The key with this is we're talking about how things are changing into something new. If I take a piece of wood and I set it on fire, it's no longer wood, it's the ash of the wood, it's the smoke and the soot, all of that stuff that's been given off in that chemical change. I can't take the ash and then all of a sudden magically put it back right into wood. It's something brand new. Rusting, you leave your bike out, your bike starts to rust, or if you have a car and you leave your car out and it's starting to rust, over time that rust will break down and you've totally changed the metal into a new composition, which is some sort of oxide, iron oxide, that can no longer go back into that actual original metal form. Tarnish happens on silver and copper all the time. Pennies turn green. The Statue of Liberty is the greenish blue color because of the tarnish, the oxidizing of the air with the actual metal itself. Again, we remove that, that's fine. If we remove that over periods of time, we actually remove all the copper and it's no longer copper. It's something brand new. Gas forms. We watch the bubbles in chemical reactions. That's telling us something's going on, a chemical change is going on. Sometimes when we mix two clear liquids, we get different colors that appear because a chemical reaction has occurred. Or sometimes we take two clear substances, we mix them together, and a bright yellow precipitate solid forms at the bottom of the actual beaker or jar, whatever it is we're using. Again, those are chemical properties. So really with 15.2, it's really just understanding what is physical and what is chemical, changes in properties, and whether or not we can identify some of those examples of that. The last part of 15.2 really started focusing on the idea of conservation of mass. Conservation of mass is actually just a concept that we cannot create or destroy matter. So if I was to burn a piece of paper, if I could collect all of the ash, if I could collect all of the soot or smoke, and I could put it all in a jar, and I could take the mass of that jar. It would exactly equal the mass of the paper as I started out. So again, conservation of mass cannot create or destroy mass. All we can do is change it from one type to another. And whatever we start with, we should end up with at the end. Other than that, those are some of those ideas and concepts you need to think about as you're kind of moving through the process and identifying whether or not you know it's a chemical change or physical change, whether it's a chemical or physical property from there. So hopefully this helps. I know it's not the typical video of me drawing things up on the board, but I wanted to give you a few minutes of what I thought you needed to know for the actual assessment, formative assessment on 15.2. There's more than that. Please use the textbook to look up some of the specific examples and things like that. And as always, if you're struggling, you need to come and talk to myself or Mrs. Villardo, and we'll get you guys on the right page. All right, sweet. Thanks for listening.